Technology is important in architecture because it increases efficiency and continually creates new architecture. For example, parametricism was introduced when new software allowed complicated shapes to be created. In architecture schools, methods of production are changing. In Syracuse, starting with our freshman class, drafting, which had been the primary method for producing drawings, has become secondary to programs like Rhino, Illustrator, and InDesign. Before everything was done solely by handcrafted models, but now we have access to laser cutting, CNC milling, and 3D printing. Laser cutting opened up the possibility of making complicated facades and conceiving building models that would have been hard to craft by hand. 3D printing has become more prevalent in modeling and is even being used to print buildings because some new materials and designs are just too complicated to cut and build. Chinese company Winsun Decoration Design Engineering has constructed a set of 10 single-story 3D printed homes which it produced in under 24 hours. The homes, printed in prefabricated panels which fit together on site, were created using Winsun's custom-built 3D printer, which measures 10 meters by 6.6 meters, and took the company 12 years to develop.
Materiality and the advancement of materials science have become very important aspects of architecture. Some new trends in materials are self-healing concrete to prevent concrete structures from cracking over time, nanomaterials, solar panels, aerogel insulation, sweating rooftops, an invention that allows the roof of tall buildings to absorb water when it rains and then release it to cool down the building when it is hot. Germ repellent, a material that can be used for hospital walls, and spider silk. Professor Hubeli's article gives a different perspective on materials used in infrastructure and architecture. The materials around the site, like sediments, are used to construct the infrastructural element into its environment. Another way technology has influenced architecture is through social media and blogging sites. Pinterest, YouTube, Twitter, ArcDaily, and countless other sites allow the flow of ideas among architects, keeping them constantly connected, allowing them to be proactive about design and material science.
Ray Kurzweil states in his article on play that tinkering or play is essential to creating innovations and new technology, like virtual reality. He gives two quotes. Technology is a way of organizing the universe so that people don't have to experience it, by Matt Frisk, and Life is Either a Daring Adventure or Nothing, by Helen Keller. Helen Keller, in this aspect, is absolutely right. Not experimenting or daring to adventure into the unknown prevents architecture or any other field from progressing, or rather discovering new things. We disagree with Frisk because technology shouldn't be considered a hindrance to experience, but rather a supplement. As the newest generation, we experience the world very differently from those generations before us, as will the next generation, and virtual reality will allow for people to experience things outside their daily lives. Virtual reality, the latest development in advanced technology and the newest playground, according to Kurzweil, poses some controversy to the concept of experience because one does not have to physically be in their desired destination to experience it. So, can one really experience a location without being physically present?
The research team at the University of Illinois at Chicago developed the CAVE automated virtual environment, the CAVE, which allows people to put on special glasses and experience a location via the 3 to 4 projectors projecting into a box lined with screens. The research is being used in order to investigate into a wide range of disciplines, including archaeology, architecture, art, biology, and many other fields. The CAVE is used for the quick analysis of projects or sites to understand the relationship between objects before they are built, even though one may not be able to experience a site fully through virtual reality. It is better than just simply reading about it and seeing 2D pictures. But when virtual reality develops smell in addition to sight and sound, there will be a very thin line between reality and virtual reality.
I'm Oliver Krailos. I'm a researcher at the University of California, Davis. I am specifically in the CAVES project, which is an interdisciplinary research project between computer scientists like myself and earth scientists on the other side, with the overarching goal to develop virtual reality as a tool to enable scientific research. And hence the CAVE was born, which is essentially a combination of 3 very big screens and a big floor, which are projected by big projectors. And then the user does not wear a display on their face, but they just wear stereo glasses, the same ones you would wear in a 3D movie theater. That was really the first time that a VR environment was working to the point where you could really do things in it.